Bismillahirrahmanirrahim. We are studying our chapter 8, that is automatic transmission and transaxle principle. Basically, this was supposed to be our last lecture of this chapter, but when I have calculated the slides, the duration of lecture become longer. So I have shortened it, and so it is divided into two parts. So this basically will be the second last lecture of this automatic transmission transaxle principle. So now straight away going towards our today's topic, and today's main topic is the wall body. Okay, wall body, purpose and function. A wall body is where most of the walls in a transmission are located. So wall body is a basically combination of many walls that are present in the automatic transmission system that contains most of the walls that are located and is attached to the case with bolts. It depends. It depends on the requirement and operation. Wall bodies can either be of cast aluminum or cast iron. So wall body, the composition of the wall body, it may be of cast iron or cast aluminum. The wall body is most rear wheel drive transmission is located inside the oil pan at the bottom of the case. So in the most vehicle which are having a rear wheel drive transmission, it is located in the oil pan at the bottom of the case. A transaxle wall body may be at the bottom of the case if we are using transaxle, which is normally or usually used in the front wheel drive vehicle. So a transaxle wall body may be at the bottom of the case or on the back side of the torque converter housing, or on the top or side of the transaxle housing, depending on the specific application. So when we are using transaxle wall body, it may be at the bottom of the case or on the back side of the torque converter housing or on the top or side of the transaxle housing, depending on the specific application how we are using. Let's see the figure 19. So this is basically a partially cut away wall body from a General Motors 4T40-E transaxle. So this is 4T40E wall body. We have different walls here along with TCC control and TCC solenoid, which energizes the walls. And there are different types of walls here in this wall body. Now, wall body have many fluid passages for the various transmission hydraulic circuits cast into them. A wall body have many fluid passages for the various transmission hydraulic circuits cast into them. These are sometimes called wormholes or worm tracks. So sometimes these are called wormholes or worm tracks. We will see this figure. Some of these passages may be widened to form pockets that contain steel, nylon, or rubber check balls. So let's see, this is a typical upper wall body showing the fluid passage wormhole. So these are basically the passages which you are seeing is the wormhole in a typical wall body. So when wall bodies have many fluid passages for various transmission hydraulic circuits coursed into them. These are sometimes called wormholes or worm tracks. Some of these passages may be widened to form pockets that contain steel, nylon, or rubber check balls. Most wall bodies consist of two or more cast sections. So in this, most of your wall bodies consist of two or more cast sections that are bolted together with a flat metal separator plate between them. So they are bolted together, but there is a flat metal separator plate between them. The upper section of the wall body is part of the transmission case casting. The separator plate, also called a spacer plate, provides rigidity and contains calibrated holes and openings that helps manage fluid flow. So we require a calibrated and specified fuel amount of fuel that has to be required to be passed through from these holes. So the separator plate, also called a spacer plate, provides rigidity and contains calibrated holes and openings that help manage fluid flow. Wall bodies contain specialized valves and circuits that are particular to the specific transmission. So along with these wormholes and worm tracks, the wall body contains the specialized valves and circuits. Those are your solenoid valves and those are your TCCM that are particular to the specific transmission. Electronic solenoids are used in a place of some valves on electronically controlled transmission oblique transaxle. So we use electronic solenoids that are used in place of some valves on electronically controlled transmission oblique transaxle. Some transmission oblique transaxle incorporates the transmission control module right on the valve body. This eliminates the wire harnesses between the transmission control module and the solenoids, which in turn eliminate connectors problem. So to ease our job to have a simplified structure or simplified operation in some of the transmission oblique transaxles in that incorporates the transmission control module right on the wall body. This eliminates the wire harness, so there is no wiring there between the TCM and the solenoids, which in turn eliminates connector problems. So we can get rid of the connector problems by placing the TCM right on the wall body and the solenoids. So a typical upper wall body showing the fluid passage wormholes as we have seen. So this is basically the electronically controlled automatic transmission transaxle use solenoid located in the wall body to control line pressure and to open and close passages in the wall body to control shifts. So basically these round assemblies, these are your solenoid valves, and this is your electronically controlled devices from where you get the electronic signal, and these solenoids operates, and when these solenoids operates, they open or close the valve of the valve body. So when they open, the hydraulic fluid flows from them. When they are closed, the hydraulic fluid stopped. So types of valves, as from your hydraulics knowledge, there are 5 types of valves which we are using in the valve body or in the automatic transmission or transaxle. That is flow directing valves, one-way valves, check valves, orifices, and manual valves. So let's see you are familiar with these. Let's see check valves. Check valves are used in the valve's body to allow hydraulic circuits to share a common passage. 3 types of upper passage. We have a ball here, we have a passage here, and we have a ball seat here, which is a left passage, right passage. So one is blocked and the one from one passage is going to the right or left. So if it is like this, the fluid is coming from the right passage and going to the upper passage. Or in this case, if it is on the right, the fluid is coming from the left passage and going to the upper. Okay. So these are the check valves are used in the wall body to allow hydraulic circuits to share a common passages. In some of the check valves, we use a spring for the return action also. Now, the manual valve is a spool valve that is moved by the shift linkage. All valves in the valve body have sharp edges on the lands. Any dirt in the valve body area can cause shifting problem due to the close tolerances between the valves and the bores and the valve's body. So basically, this is your valve body, and this is your manual valve, and these are the basically sharp edges, lands, and basically these are the when we are having this position, there is an opening. When we have this position, it means this is the closed position. So it's the help of this spool and the position of these sharp edges or lands determines the hydraulic flow. Now, transmission range switch mounted here on the transmission. This is the shifter cable. This is the figure of transmission range switch on a rear wheel drive automatic transmission mounted directly to the side of the case of the unit and accessible from underneath the vehicle. So basically, this is a transmission range switch. We have a transmission range in automatic transmission. So this is that switch which maintains the range in an automatic transmission. So this is its shifter cable. Now, as we know, this is the transaxle we have. This is the input shaft speed sensor here in the front. And at the rear, we have the output shaft speed sensor. And this is the solenoid connector and the transmission range sensor, which we have seen here. Okay. The speed sensors are used by the powertrain control module. So the speed sensor, the input and the output speed sensor are used by the powertrain control module or the transmission control module, whatsoever you are using, to control, shift, and detect faults such as slippage when the two speeds do not match the predetermined ratio for each gear commanded. So we have these input and output switches from where we can get the signal at the PCM or TCM, from where we can detect the fault of the slippage between the two speeds which are not matching the predetermined gear ratio which we have given the command. Okay. Now the electronically controlled transmission. Electronically controlled transmissions and transaxles have been used by most of the vehicles manufacturers since the early 90s. So since the early 90s, we are using the electronically controlled transmission and transaxle by the OEMs. Compared to the hydraulic controlled units, we using the powertrain control module or the transmission control module to operate the control shifting results in a smoother operation. So due to help of this electronically controlled transmission, instead of that hydraulic control units, we are using in PCM or TCM because of the control shift results in a smoother operation. Also, the powertrain control module or the transmission control module can monitor the circuits and the set a diagnostic trouble code if a fault is detected. Okay, so this comes the end of this lecture. This was the second last lecture. Next lecture, as you know, when I give the last lecture of that topic, I give a quick recap of all the slides which we have studied in that chapter, and then we goes to the last topic or last slides of the chapter. So next lecture will be the last lecture of this automatic transmission, the chapter 8, which we are studying.